Hello, Algebra 278. Mr. Lawrence here, and we're going to do some factoring review for two reasons. One, I know you don't quite get factoring, okay, and that's always bothered me. It's not about you. It's been happening the past 5, 6 years. It used to be my students totally got factoring. They left and they were factoring masters. And about 6 years ago, something like that, all of a sudden kids just like don't get it. And I think it's because of number sense. I think it's because maybe you were allowed to use a calculator too much uh, at a younger grade, and I don't know. I'm not blaming any specific teacher, okay? But that's one of the reasons I want to hit this again because you need to understand factoring. You're going to be showing it in geometry. You're going to be showing it in algebra 2. You got to be good at it. Okay, so let's learn it now so that when you get up to geometry and algebra 2, it'll be a lot easier. And the second reason is I'm going to reteach another way, a more traditional method. Not today. Today I'm doing a traditional method, but when we do some trinomials, I'm going to do them more traditionally over the next couple days because the high school teachers have said it works better for them to do it that way. And initially I didn't do it that way. So if you never got factoring, this is going to be another chance. Maybe you're a little bit older, a little bit more mature, and you can have the opportunity to figure this out. Anyway, so let's get down to this. We're going to start off with two special patterns of factoring. One is called the difference of perfect squares, and the other one is called a perfect square trinomial. And we need to know these really well. Now, I've got a double distribution problem set up in each case. I'm going to double distribute to show you what these special patterns look like. And this should be reviewed, so it should be coming back to you. So I'm going to multiply the 3x times the 3x and the 3x times the negative 5. So I'm going to get a 9x squared minus a 15x. And then I have to distribute the 5. And so there's going to be a positive 15x and then a negative 25. And remember, I like to set it up so my like terms are obvious. Some of you don't do that, and that's fine. That's just how I like to do it. These will cancel because one's positive and one's negative. They're inverses of each other, additive inverses. So I have a 9x squared minus 25. This pattern is the difference of perfect squares. If I go to factor it, it's going to look just like what I started with. Okay, how do I know? Well, if you look, this is a perfect square, right? And the square root of it is 3x. 25 is a perfect square. Square root is 5 plus or minus 5, right? And it's subtraction because this is the difference. Difference means to subtract. So since I've got 3x plus or minus 5, I'm going to have 3x plus 5 in a quantity and 3x minus 5 in a quantity. And notice that's exactly where I started with. We're not going to be double distributing unless we're checking our work. We're going to be factoring, all right? So let's do a couple of these difference of perfect squares. Number one here, is it a difference of perfect square pattern? Well, let's see. Just giving myself some room to work here. Sorry about that. All right, so number one, we've got x squared minus 16. Well, is x squared a perfect square? Sure is, and the square root is x. Is 16 a perfect square? Yeah, and the square root is plus or minus 4. Are we subtracting them? Yes, we are. So this is the difference of perfect squares. It factors with two quantities. We'll have an x plus a 4 and an x minus a 4. And that's it. That's it. Now, think about A, B, and C for a minute. A would have been 1, B would have been 0, and C would have been negative 16. You notice how the C is negative? That's not a Wendy's double stack. That's when we get one of each sign. Just trying to give you some ammunition here to help you recall or have it sink in better how to factor this difference of perfect squares pattern. All right, there's two more problems, number 2 and 3, the red ones. I'd like you to pause the video now and go ahead and give them a shot. All right? Please don't keep watching. Please pause the video and see what you can do. Here come my solutions. If you haven't done numbers 2 and 3, pause. All right, here we go. First of all, 9x squared is a perfect square. Square root is 3x. 25 is a perfect square. Square root is 5, plus or minus. It was being subtracted. Okay? So this is the difference of perfect squares. I'm going to get a 3x plus a 5 in a quantity and a 3x minus 5 in a quantity. Did I just do that problem? Was that problem number 1 all over again? Yeah, it sure was. Sorry about that, ladies and gentlemen. That's okay. Number 3. Again, if you haven't done it yet, pause it. All right. Perfect square? Yep. 9x is the square root. 4 plus or minus 2. Subtraction. I like it. 9x plus 2. 9x minus 2. Now, some of you are going to get ready to ask me, you said, well, I wrote it this way, and I'm not going to answer if these two are the same. You are smart enough to know if these are equivalent to each other and why if they are. You should know. Okay, now problem number 4 I'm going to talk about a little bit. It doesn't look like the difference of perfect squares, except I see a GCF hiding in here. Yeah, do you see it? I see a 2x. So I'm going to factor out a 2x. Now the 2x doesn't go away. It's got to stay out front. Then I'll have a 9x squared minus a 16. That equals 0. Don't lose that. Inside here is the difference of perfect squares, because this is a perfect square, 3x. This is a perfect square, plus or minus 4, and it's being subtracted. So I've got to factor again. I'll have the 2x out front. Don't lose them. Then I'm going to have two quantities. Why two quantities? Because this part of the problem breaks up into two quantities, into 3x plus 4 and 3x minus 4. Now, it equaled 0, which means I have to solve. So remember, I take each quantity, and notice I underline the quantities, even though this one's not in parentheses, it could be, and I set them equal to 0. I go 2x equals 0, and I solve for x. 3x plus 4 equals 0, and I solve for x. 3x minus 4 equals 0, and I solve for x. Okay, so this is still factoring, but I actually have to solve, using factoring to solve these. Divide by 3. So x is going to equal negative 1 1/3. Okay, and then here I'll get 3x equals 4, divide by 3, and I'll get x equals 1 1/3. This should be familiar. Okay, I'm expecting you to know how to do this. And so my three solutions for x are 0, and then 1 1/3, and negative 1 1/3. And there you go. All right, one last thing about the difference of perfect squares. Is this the difference of perfect squares? Yes, because I could rewrite it as 9 minus x squared. Square root of that would be 3. Okay, square root of that would be x. There is subtraction. It would factor as 3 plus x and 3 minus x. And there you go. Okay, let's go talk about this other one now. It's similar. It's called the perfect square trinomial. And I'm going to start similar by double distributing. Okay, so I'm going to double distribute here and get 9x squared, and then a positive 15x, and then 5 times 3x is going to be a positive 15x. Notice the signs ended up being the same, whereas in this pattern they ended up being opposites. All right, and then finally 5 times 5 is 25. When I multiply together, I'm going to get 9, or excuse me, when I combine like terms, I'm going to get this. And this is a perfect square trinomial. If I factor it, I will end up with those two quantities I started with. Is 9x squared a perfect square? It sure is. The square root is 3x. Okay. Is this a perfect square, 25? Yes, 5. And I'm only going to use the positive square root here. Now, I'm going to get two quantities. They're both going to have a 3x and a 5. And this is where the Wendy's double stack is so important, okay? A plus in the back is the Wendy's double stack, positive and positive. That's how a perfect square trinomial will always look. It'll be the square root plus the square root twice, or it could be the square root minus the other square root twice, meaning in both quantities. So let's try number one here, okay? Is the first term a perfect square? It is. Is the last term a perfect square? It is. Now, by the way, I forgot to mention the last problem. I need to multiply these two together, 4x, and double it, 4x times 2. Does that equal 8x? It does. So this is a perfect square trinomial. Once you know this pattern, this type of factoring is almost mindless. It's so simple. See, I've got my square roots, right? Plus in the back, double stack, they're both positive. Okay, that will always happen. For a perfect square trinomial, that last term will always be the same sign as the first term. Usually it's positive. Okay, if they're both negative, you can do a little adjustment, but usually it's positive. All right, let's try number 2 here. Okay, square root is 3x. Square root is 5. Multiply these two together, 15x. Double it, 30x. Uh-oh, these aren't a perfect square trinomial. I'll bet you I made a mistake when I was writing it down. Okay, tell you what, let me change that from a negative 10x to a negative 30x. Of course, you can't do that on a problem. I think I just made a silly mistake when I was making this problem up. But it's always important to check. 3x times 5 is 15x. Doubled is 30x. After you double it, it must match this b term. Okay, so now that it's a perfect square trinomial, I know I'll have two quantities. Or, since I know the quantities are going to be the same, you could write one quantity squared. Yeah, I'll do it both ways. How's that? Okay, so I am going to get a 3x and a 5, a 3x and a 5. And I look at that last term. It is positive, right? I need to double stack. That's going to be boom and boom, like that. All right. Hopefully this is coming back. This should just be review. Oh, I said I was going to do this 2 ways. Here's my other way to factor it. There you go. And some of these are, sometimes it is easier to do it this way than it is to do it that way. And you can't see that at the moment, but we may get to some problems where you'll be better off doing it this way. If you ask the honors kids, they've done ones like that. Okay, problem 3. I'd like you to pause and try it on your own. Okay, here comes my solution. Hopefully you've already done problem 3. I'm going to check and see if it is a perfect square trinomial. So I'm going to get 8x. And that's going to be 5. When I multiply together, I'm going to get 40x. If I double 40x, I get 80x. It is a perfect square trinomial. I'm going to go with 2 quantities. I'm going to have an 8x and a 5, 8x and a 5. I check that third sign. It's positive. A plus in the back means a Wendy's double stack. It means these are both negative. And there it is. And again, if you would rather do it this way, in some situations, that's a better answer, okay? But both are acceptable just when we're factoring. Number 4, you go ahead and do it. Pause that video. Here comes my solution. All right, I'm going to take the square root. Going to double, get 44x. Oh, excuse me, going to multiply, then double. And I am going to get 88x. I like it. 11x, a 4, 11x, the 4, plus in the back, the Wendy's double stack. This time they're both positive. All right. That's it for the video. Of course, if I had set it equal to 0, you would have to do it like in that one problem. Okay. That's your video for tonight. Mr. Laurence signing off. Have a good night, everybody.